geometric series, so you can assume there's a common ratio. What's the ratio in this one? 1 what? 1/2. What's the ratio in the second one? 2. And we said the ratio in the third one was what? Negative 1/3, right? So for this question, it asks, for each of the following infinite geometric series, find the several partial sums and the sum if it exists. The partial sums and the sum if it exists. So what's the sum of just the first term? Well, 1, right? What's S1 plus S2? Well, that's 1 plus 1/2, which is what? Close, 3/2. 1 plus 1/2. And then what's S1 plus S2 plus S3? Well, that's going to be 1 plus 1/2 plus 1/4. What does that equal? Fractions. I know you love fractions. Come on, kids. What is it? 7/4. So I love it like that. And then S1 plus S2 plus S3 plus S4. So that's going to be, I'll just simplify it, 7/4 plus 1/8. So what's that going to be? 15/8. And you could keep going, theoretically, right? Theoretically. What about this one? What's the first partial sum here? And I can't remember. Remind me. Is my notation, does that look a little better? Okay. So S1 in this case was 1. What's S2? For this one, what's S2? 3. What's S3? 7. S4? 15, because we're adding 8. Okay. Now for this one, ooh, fun with fractions. Do you guys like fun with fractions? So you got to deal with fractions. What's 14? What's 14 times 3? 42 minus 2/9, like this. 49ths, like that. And could you find S5 if you really wanted to? Just practice some fractions. It'd be 49ths. And we're adding something this time, right? What are we adding? 2/27. So what is that going to? Oh, it's multiplied by 3. So what do you get? 120 plus 2/27. So what do you get? 122 over. And it's freaking out on me. So that's okay. I'll just do this really big. 122/27. So those are the parts. And the sum if it exists. When would the sum not exist? And the sum if it exists. When would the sum not exist? This one just keeps getting bigger, right? So this one goes to infinity. It diverges. What's the point of writing out the partial sums? It helps you give you an idea of where it might be going. So what about the first one? Where does this look like it's going? What's the sum going to be? It goes to 2. That's right. It does go to 2. What about over here? What does this one look like it goes to? Well, the other one, you could come up with a pretty good idea, but does it look like this one's converging? Does it look like it's converging?
Yes.
Yeah, it does look like it's converging. What does it look like it's converging to?
0.
Well, no, the terms look like they're getting closer to 0, right? But just because the terms are going to 0, does that mean the series goes to 0?
No.
To have a chance of converging, the sequence has to go to 0. But just because it goes to 0 does not mean that the series itself goes to 0. Do you know what the classic example of this is? Seen this. The sequence S1, 2, 3, 4, Sn has a limit L written. The limit as n goes, thank you. The limit as n goes to infinity. Of Sn equals L. If Sn is as close to L as we please whenever S is sufficiently large. Something is a limit if we can always get closer to it. You could say, how do we prove that wall is the limit? Let's say I'm behaving in such a way that gets me closer to this wall. The action of me getting closer to the wall would be the limit if, for whatever number you specify, I can always get that close to the wall, or closer than that. Regardless of how small you say, if this action takes me that close, the wall would be the limit. So the harmonic series, 1/2, 1/3, 1/2, 1/3, 1/4, 1/5, 1/6, like the harmonic sequence. Does that converge? It converges to 0 because it gets arbitrarily close to 0. But if you add all the pieces together, do the pieces converge? No. Harmonic is awesome that way. It's a great example. Does that screw everything up? Be very careful about it. So that finite one, I'll write it over here. The finite one is a times 1 minus r to the n all over what? 1 minus r. And you can see why this easily, okay, so let's just do this step by step here. So if we wrote this out, another way to write this is 1 minus 1 over e to the n over 1 plus 1 over e to the n, right? What do these things do? As n goes to infinity, what do those two highlighted things do? As n goes to infinity, Emily, what are these?
Are you talking to me?
Yeah.
Okay. Yeah, they go to 0.
They go to 0. These tend to 0 because these get infinitely big, 1 over something that's infinitely big. So this whole thing goes to 1. What would this series do? If you added these all up, would this converge? If you turn this into a series.
Doesn't it, if it's a series, doesn't the sequence have to converge to 0?
To have a